Improper integrals. How do we do improper integrals? In this video, I will give you guys 8 examples on the type 2 improper integrals. And remember, for type 2, it means that we will have a vertical asymptote going like this, or maybe going down like that. Then the interval that we're integrating, so be really careful about that. If you look at the first one, we have the integral going from 0 to 1 of e to the 1 over x squared. And if you graph this function, you will see that we do have a vertical asymptote at 0. So that makes this the type 2 improper integral. So let me just indicate that real quick. VA at x equals 0, but don't worry, let's just go ahead and integrate this. And remember, because we have a vertical asymptote here, this is technically 0 plus. And the reason it's 0 plus rather than 0 minus is because we are going from 0 to 1. We have to be a little bit bigger, right? We have to approach 0 from the right hand side so that we can avoid exactly 0. Anyway, let's just go ahead and do the integration, because we can do u sub that u equal 1 over x, which is just x to the negative 1. Differentiate both sides. du is equal to negative 1 over x squared, because we can bring this power to the front, minus 1. And then of course the dx. And then multiply this on both sides, we get dx equals negative x squared du. And now take this integral to the happiest place for the integrals, namely the u world. We get the integral. This is when x is approaching 0 plus. If we put that right here, 1 over 0 plus is positive infinity. So you will approach positive infinity here. And then when you put 1 in here, 1 over 1 is just 1. So you will be going up to 1. This is kind of weird because this is bigger than that. But don't worry, check this out. Here we have e, and then 1 over x is our u, over x squared, and then the dx is that, which is just the negative x squared du. And this is so nice because x squared cancel out, and you see we do have the negative. And just like what we did in the previous video, we can actually use this negative to switch this and that, right? So I'm going to just write down we will be integrating, and of course we can finish everything that you will. And again, I'm going to use this negative. I will just put down 1 here and then infinity here. That's the order that we like, right? The small on the bottom here, and then the top one should be bigger. All right, and then we have e to the u du. And you see right here, we'll just have to integrate e to the u in the u world, which is just e to the u, and then plugging, right? And you see, when we plug in infinity, we get e to the infinity, and then minus the second term, which is e to the 1. E to the infinity is just infinity, and minus e to the first is just e, which is finite. Infinity minus e is still infinity. So as you can see, this right here is infinity, but perhaps we'll just say this integral diverges. For number 2, we have the integral going from 1 to e of 1 over x times square root of ln x. So where is the vertical asymptote? 1. Because when you put 1 inside here, ln 1 is 0, and that will make the whole bottom 0. Yeah. So here, let's go ahead and just indicate that we have a vertical asymptote at x equals 1. And of course, we can take off this easily with u sub. And again, here, this is technically 1 plus then, because again, we have to avoid exactly 1. Take the limit, that's the idea. Anyway, let's go ahead and just do u sub that u equal ln x, and then we see that du is just equal to 1 over x dx. So you do see the 1 over x and the dx right here. So if you would like, you can actually just replace right away, or if you would like, you can also just multiply the x on both sides, so you can see the cancellation. So it's up to you. Perhaps I'll just show you guys the cancellation. It's not bad. Multiply the x on both sides like this. And now take this integral to the u world. Well, this is x is approaching 1 plus. You put it here. ln 1 plus is 0, but it's a little bit bigger than that. So it will be 0 plus. And then if you put e in here, ln e is 1. So it's just 1 right here. And then here we have 1 over x square root. This is the u, and this is x du. And I told you we can just have this and that cancel. So if you really want to skip this step, it's totally okay, because 1 over x dx, that is exactly the du. But anyway, we will integrate this, and again, we'll finish everything that you will. And to do that, we are looking at the integral from 0 plus to 1 over square root. That's the same as u to the negative 1/2 power in the u world add 1 to the power, negative 1/2 plus 1 is positive 1/2, and then divided by the new fraction, right? New power, which is going to be multiplying by 2 over 1. So we get 2, and then u to the 1/2 is the same as square root, and then we have the u, and then we go from 0 plus to 1. Plugging. So the first term is 2 square root of 1, and then minus, put a 0 plus here, we get 2 square root of 0 plus. Alright, this right here is just 0, that's just 2. So altogether we just get 2, and this right here converges to 2, and then we're done. Number 3, we are going to take care of the integral going from 0 to pi over 2 of tangent x. Well, let's take a look at the graph of tangent x real quick. Let me just remind you guys, we have a vertical asymptote at pi over 2. So that makes this improper, because if you take a look, this is the graph for tangent x. It goes like this, right? Okay, so let's just go ahead and just write this down real quick. Vertical asymptote at x equals pi over 2. And technically, we will just have to integrate from 0 and then stop right before, right? But that's the idea of taking the limit. Approaching pi over 2 from the left-hand side. So this is technically like this with a minus. So just keep that in mind. Once we do the limit, that will be helpful. All right, so we know the integral of tangent x, we have did that many times, is ln absolute value of secant x, but the inside will be positive, so you can just put down parentheses, and then we just have to go from 0 to pi over 2 minus. Plug in and see what happens. So the first term is ln secant pi over 2 minus, and then minus the second term is plugging 0, so we get ln parentheses secant 0, and then parentheses and then parentheses. All right, now this is the part that's going to give us trouble. Let's talk about what secant pi over 2 minus is. So if you look at the graph of secant x, again, this right here also has vertical asymptote. So I'm just going to put on a dashed line like this. This is at pi over 2. And secant is a reciprocal of cosine. And the graph looks like this. Upside, like a u, and then the other one's like this, right? So open up u. But anyway though, you see that if we approach pi over 2 from the left hand side, secant x is going to go to infinity. So this part is going to be infinity. And we see that we just have infinity here. And if you do ln of infinity, that's still going to be infinity. What's secant of 0? It's just 1. And then ln 1 is just 0. So we have infinity minus 0. So you know it's going to be infinity. Right? The whole thing is infinity. And of course, we can just say this improper integral diverges. Number 4, we have the integral going from 0 to 1 of ln x inside parentheses, and then square, and then divided by x. First off, when x is 0, this is going to be crazy. On the top, inside here, we get negative infinity if x is approaching 0 plus, right? And then square that is infinity over 0 plus. You just have a vertical asymptote. So let's go ahead and just write that down real quick. Vertical asymptote at x equals 0. Same thing, right? We do the 0 plus just like what we have done earlier. And for this one, you do not have to use integration by parts. You can just do u sub. If you have ln x over x squared, this integral, you know, it is integration by parts. But for this one, we can actually just do u sub. Because we can let u equal ln x, and then du is just equal to 1 over x dx. And you see that we have the 1 over x dx already. So this right here is really just to integrate. And now, when x is 0 plus, you put it here, ln 0 plus is negative infinity. So you will approach negative infinity. And when x is 1, you put it here, ln 1 is 0. So we have u going from negative infinity to 0. And then this is u square. And then this part right here is precisely our du. So we can just, you know, pair them up. And let's say that's the du. So it's not so bad. Let's just integrate and this is what happens, right? Let's see, this right here gives us 1/3 u to the 3rd power. And then we'll just have to plug in, right? And then let's see, we will get 1/3 and then 0 third power and then minus 1/3 and then negative infinity third power. Yeah, check this out. This is 0. Negative infinity to a third power is negative infinity times 1/3 is still negative infinity times negative. We get, well, I should say like this, negative and then negative infinity. Yeah, but anyway, this right here is clearly infinity. So this right here diverges to infinity. Yeah, just like that. All right, number 5, we are integrating from 0 to 1 of 1 over square root of 1 minus x squared. Where is the vertical asymptote? At 1, right? Otherwise, you see that on the bottom we get 0. So let me just indicate that real quick. Vertical asymptote at x equals 1. And technically here, we are doing 0 to 1 minus, right? So we are approaching 1 from the left-hand side. What should we do to integrate this though? Well, all we have to do is just know our derivative really well, because the derivative of inverse sine of x will give us 1 over square root of 1 minus x squared. So integral of that is just this. All right, and then we go from 0 to 1 minus, and plugging, we get inverse sine of 1 minus, and then minus, plugging 0, we get sine, and then inverse, and then 0, like this. Okay, in fact, this right here is a good number. To evaluate this, we will just have to ask ourselves, sine of what angle will give us 1? So let me just put that down right here for you guys. If you're looking at inverse sine of 1 is equal to, I don't know, let's just say question mark. You can do the original sine on both sides. So you get 1 is equal to sine of what? And in fact, there are infinitely many solutions to this right here, but you're going to pick like the first one, and that is pi over 2. Sine of pi over 2 gives you 1. So that's because the range of inverse sine function, it goes from negative pi over 2 to positive pi over 2. So this will be the only solution to the original. So this right here is really nice. We get pi over 2. And then inverse sine of 0 is just equal to 0, because the original sine of 0 is 0, so it's 0. So the answer is just pi over 2. Yeah, very nice, huh? Okay, for number 6, we have the integral going from negative 1 to 8 of 1 over the cube root of x. If you plug in negative 1 here, cube root of negative 1 is negative 1, that works. If you plug in 8 in here, cube root of 8 is 2, that also works. But remember, we have to pay attention to, is there any number that will make the denominator 0, right? And yes, we do. This right here, it does have a vertical asymptote at x equals 0. And if you look at the graph of this guy real quick, it looks something like this. I'm just going to put it down real quick like this. We have a vertical asymptote at 0. And when x is negative, you have a graph that goes down below like so. And then if you have x being positive, you have a graph that's above like so. And we are going from negative 1 and then to 8, like this. And we're just going to find this and that. The way to take care of this is that do not include 0. We have to break that part into 2 parts. So here we go. Firstly, we are going to look at the integral going from negative 1 to 0. But we have to avoid 0, so we are going to, do 0 minus right here. And then we have this guy, which I'm just going to write it as x to the negative 1/3 power, because we are about to integrate that. And then we are going to add, well, we have to, this was 0 minus, we have to pick it up, but we cannot use exact 0, we use 0 plus. So we go from 0 plus up to 8, and then again, we can write that down as x to the negative 1/3 power. Good. And now we can just take care of each and every part. For this one, we add 1 to the power. Negative 1/3 plus 1 is 2/3. Yes, yeah. And then divided by the new power, we get 3 over 2. All right, so for the first one, we get 3 over 2 and then x to the 2 over 3. And then we will have to plug in numbers, right? So plug in -1 and plug in 0 minus. So that will be the first part right here in red, I would say. And then for the second one, I will do this in blue. I'm going to add, well, 3/2 x to the 2/3, and then we will have to plug in 0 plus and then 8. All right, so for this one, okay, let's just do the work. Plug in 0 minus, which is just 0 because this guy is really nice. Here we have 3/2 times 0 minus and then 2/3. This is the first one, and then minus parentheses 3/2 times -1 and then to the 2/3. All right, good. And then we are going to add this one. I'm going to do it in blue in terms of plugging the number. We get 3/2 and then 8 and then 2/3. And then plugging the 0 plus, we get minus parentheses 3/2 and then 0 plus and then 2/3. Whew. Yeah, so far so good. Okay, check this out. This is just 0, so that's good. And then this is going to give us +1. Right? This is going to give us +1. So we will have to minus 3/2. All right, so this right here actually converges because when we have the trouble number here, it does give us a finite value, but then we just have to do the fractions. This part right here is just 0 as well, but let's compute a to the 2/3. And let me just remind you guys the good old algebra days. 8 to the 2/3. What you do is you look at this as the cube root, and you do that first. Cube root of 8, and then you do the square on the outside. Cube root of 8 is 2, and you square that, so the answer for this is 4. Yeah? Okay, so this right here is 4, but you multiply by 3/2. So work out the fraction, you will get 6. So right here, we just have to add 6. So perhaps just keep the same color, 3/2. So we are just going to add 6 and then minus 0. Man, this has a lot of fractions. All right, so finally, you just do 6 minus that. So it's 12/2 minus 3/2, which is 9/2. So altogether, this right here converges to 9/2. I hope I didn't add the fractions wrong or subtract the fractions wrong. Yeah, so that's it. For number 7, we have the integral going from -2 to 1 of 1/x to the 4th power. This is similar to what we did earlier because the vertical asymptote is not at the end point. It's actually at 0. It's just somewhere, right, in between. So let's just indicate that vertical asymptote at x equals 0. And if you want to see the graph for 1/x to the 4th power, you will look something like this. Like a volcano, very similar to the example that we did in class. In fact, I just changed the 2nd power to the 4th power, right? But anyway, let's just go ahead and do all this. We go from -2 to +1. So we are taking a look at here and also here. Of course, we do not want to have exact 0. So what we do is break it apart, right? So look at 0 minus and also 0 plus. All right, so for this one, we are going to get the integral going from -2 to 0 minus first. And then look at this as x to the -4th power dx. And then we are going to add, we are going to pick that from 0 plus to 1, and then x to the -4 dx. Now, integrate this, add 1 to the power, which is -3, divided by the new power, and we get that. And we get -1/3, and then perhaps let's just put the x to the -3 power down here and becomes x to the 3rd power. Okay, and then we will have to go from -2 to 0 minus, and then we are going to add it with this one, which is -1/3x to the 3rd power, but plug in 0 plus and 1. Yeah. All right, so let's just go ahead and do the plugging. For this, plug in 0 minus first, and we are getting -1/3 times 0 minus and then to the 3rd power. That's the first term, minus the second term, -1/3 times -2 and then to the 3rd power. For this, of course, I'll plug in the numbers in blue. We get, well, first we put down plus, wrong color. We first put down the plus, and then we plug in 1. So we have negative 1 over 3 times 1 to the third power. And then minus, plugging 0 minus. So we get negative 1 over 3 times, 0 plus. Yeah. Okay, cool. Very cool. Not really, because you see that this right here, 0 minus to a third power, that will still give you a negative, right? So it's technically still 0 minus. And then multiplied by 3 is still 0 minus. And then on the top here, we have negative 1 divided by 0 minus. So altogether, this will give us positive infinity. And this number we don't really care about. I will still compute it real fast. This is 1 over negative 8. Right? But that's how I make this positive. And then 8 times 3 is 24. And then for this, we are going to add, this is just 1 over 3. So that's good. And then minus minus becomes plus, and then we have an infinity, like so. As you can see, we have an infinity and a plus infinity. So this right here is not debatable. It's just go ahead past the infinity. And you can look at it from the graph right here as well, right? Infinity. So this right here diverges to past infinity. What if this right here gives us a red infinity and it's positive, and this right here gives us a negative blue infinity? In that case, we cannot do a thing. And the idea is, whenever we break down an improper integral into two pieces, as long as one piece, or one part of them, diverges, the whole thing diverges. End of arguments, end of the work, yeah. But this right here, don't even worry, because I think it's really clear. That's it. I'm going to ask you guys a question that has to do with partial fractions. This is the one. If you look at the bottom here, can we factor it? Yes. So let's go ahead and factor it. We get x minus 1 times x plus 2. And you see that when x is 1, we get a 0 on the bottom. At 1 over 0, we get that vertical asymptote. So let's go ahead and indicate that vertical asymptote at x equals 1. At 2 is okay. Sometimes, if we have like both ends gives us vertical asymptotes, in that case, we still have to break down into two pieces. But usually, I won't ask you guys those kind of questions on the test. But anyway, partial fractions in action still go from 1 to 2, and this one technically is 1 plus. So just keep that in mind. Keep that in mind. For the first fraction, we will have some number over x minus 1, and then for the second fraction, we will have some number over x plus 2. Good. All right. To figure this out, we go back to the original and cover this, and we will have to ask ourselves, what do we need to plug in right here to make x minus 1 equals 0? And the answer is 1. And then we're going to put a 1 in here. 1 over 1 plus 2, which is just 1/3. Good. Well, to figure this out, we go back to the original and cover this up. And how can we make x plus 2 0? X has to be negative 2. And we put it here. And we get 1 over negative 2 minus 1, which is negative 1/3. Perfect. So now we can just go ahead and integrate. For the first one, we'll just have 1/3 and then ln. And we don't need to have absolute value because on this interval, the x minus 1, x plus 2 will be positive, so don't worry. So let me just put on parentheses, x minus 1, and then we are going to minus 1/3, ln parentheses x plus 2. And again, you see that this is the integration, and the coefficient of x is just 1, so we do not have to divide anything else. So that's really nice. And before we plug in the numbers, perhaps it's a good idea to combine the natural logs together first. And when we do that, we will get 1/3 first. So let's put that down. And then ln. This will go to the top because it has positive right here. Over this right here will be on the bottom because it has the negative, right? Cool. And then we plug in. All right, plugging 2, we get the following. We get 1/3 ln parentheses 2 minus 1 over 2 plus 1. Oh, sorry, 2 minus 1 over 2 plus 2. and then minus parentheses. Okay, plugging 1 plus, we get 1/3 ln parentheses 1 plus minus 1 over 1 plus 2. Okay, whew, a lot of work. Yeah, I know. But you know what? This is finite. Let's take a look at what this is. This is 0 plus. 1 plus minus 1 is 0 plus. And again, remember we're taking a limit. 0 plus divided by this is positive, so it's still 0 plus. So in fact, here we get ln of 0 plus. And then we have the 1/3. But this right here is negative infinity. Times 1/3 is still negative infinity. And then negative becomes positive infinity. So in fact, all in all, we get positive infinity. I don't really need to worry about what that is. It's just finite. Plus infinity still gives us infinity. Therefore, you see that one diverges. And with that, we are done. And remember, I did a video with the type 1 improper integrals. So if you need to watch that, be sure you click on that video. I'll see you guys there. And if you guys need more help, you guys can subscribe for my channel. You guys can subscribe to the channel so that you guys can get the future videos. And as always, that's it.